Time for Pluto. Video 54. We finally got to Pluto. Now what I'm going to do here is, even though Pluto is not considered a planet anymore, I'm going to go ahead and give the vital stats on Pluto. I have a column here on this sheet that I made for you. We're going to go ahead and fill this out. Semi-major axis 39.5 AU. So between Saturn and Uranus, about 10 AU. Between Uranus and Neptune, about 10 AU. Between Neptune and Pluto, about 10 AU. Okay? But it turns out that the eccentricity, I'll go ahead and put this number in here, is so large, 0.25, that for about 20 years out of its orbit, Pluto is actually closer to the Sun than Neptune is. Okay? It actually gets closer than Neptune. When I first learned astronomy back in the late Bronze Age, at that point, actually Pluto was closer than Neptune, so that does happen because of this huge eccentricity. Orbital period 248 Earth years. It's a long time. Rotational period minus 6.4 Earth days. Again, that minus sign means that its obliquity is larger than 90. I'll go ahead and write that number down here. It's actually 123 degrees. So the north pole of Pluto is actually sort of below the ecliptic and not above it. Okay. So every time this number is negative here, this number here is bigger than 90. That was the case for Venus, for Uranus, and now for Pluto. The mass is very small, 0.0022 Earth masses. Okay, tiny. Radius also small, 0.19 Earth radii. Okay. Now notice here real quickly that the mass and the radius indicate to us that Pluto is breaking the pattern. We had 4 terrestrial planets, all pretty decent sized, right? And then we have 4 really, really big gas planets. And then we have Pluto, which is small again and terrestrial again. Actually, it's made of ice, whereas the inner planets are made of rock. Pluto is mostly ice. And not only that, but it has a very eccentric orbit, and its orbit is also tilted relative to the ecliptic by a lot. Okay, so it kind of breaks all the rules. Nice little rule here too that it breaks is there's actually 5 moons of Pluto with cool names like Charon and Nix and Hydra and Styx, things like that. Okay, so five moons of Pluto. The density is quite low because it's, like I said, it's mostly ice. It's 1850 kilograms per meter cubed. It is icy with some rock thrown in. Okay, kind of like a comet. It kind of is made of the same stuff a comet is, it's just bigger. Okay. Magnetic field 0. And finally, surface temperature is 44 kelvins, which is the same as about negative 380 degrees Fahrenheit. So the thing here is that Pluto kind of breaks the rules. Highly eccentric orbit. It is tilted, that orbit is tilted a great deal from the ecliptic. Much more than Mercury is tilted 7 degrees. I think Pluto's tilt is like almost 20 degrees. So if all the if all the planets orbit on the tabletop, nice and smooth on the tabletop, then the orbit of Pluto is tilted about 20 degrees relative to that. It's not a gas giant. It's a small little thing. So before it was demoted, and when I taught astronomy before it was demoted, I described Pluto as sort of the weird uncle that you keep in the attic when decent people come over. Okay, it's sort of kind of embarrassing, kind of breaks all the rules, nice guy and all, but kind of breaks the rules, and so you don't bring him out when nice people come over to visit. So I was kind of emotionally, I was against the idea of the demotion of Pluto, but scientifically I think it was a good idea. Here's what happened. Okay, make sure I said everything I want to say about Pluto before we go on. Back in the early 2000s, 02, 03, 04, something like that, a new object was discovered out beyond Neptune. Okay, now several objects had been already discovered, but one of them was discovered that was actually larger than Pluto. That object's name eventually came to be Eris. So it orbited just a little bit beyond Pluto, okay, but it was larger than Pluto. It was, larger than 0.19 Earth radii. And so the question was, do we make Eris planet 10? Because at this time, Pluto was the 9th planet. The question is, do we make Eris a new planet or not? And so the debate raged. Now, what you have to know is that Eris and Pluto both reside squarely within the Kuiper belt. And you'll remember from my early sort of schematic diagram of the solar system that I drew up here, there are 4 terrestrial planets, then the asteroid belt, and then 4 big Jovian gas planets, and then the Kuiper belt. The asteroid belt is made up of rocky bodies. The Kuiper belt is made up of icy bodies. And both Eris and Pluto are within the Kuiper belt. So when Eris was discovered, there were a couple issues. One is, should we make it a planet? It's bigger than Pluto, so if Pluto's a planet, Eris should also be a planet. Right? You got to be consistent. So do we make it a planet? Also, there was the growing realization that Pluto and Eris were just 2 particularly large members of a huge swarm of hundreds of thousands of bodies that made up the Kuiper belt. In this way, it was kind of like the discovery of Ceres in 1802. When they discovered Ceres between Mars and Jupiter, the asteroid Ceres, they said, oh, it's a new planet. And so they called it a planet for a while, but then they discovered more asteroids. And then they discovered the asteroid belt. And so they thought, no, we can't call that a planet because then we'd have 100,000 millions of planets. And what would how can you have Jupiter be the same thing as a little rock 100 meters across? So Ceres and the other asteroids were grouped into that population known as asteroids, and after a few years were no longer considered to be planets. Well, the same thing happened here. Pluto was discovered, they called it a planet. Eris was discovered, the question came up, is Eris a planet or not? Ultimately, they decided no. There are 3 points to planethood. All right, new color here. Okay. 3, to be a planet, comma, a body must, colon, 1, orbit the sun. Okay, so far so good, right? Both Pluto and Eris orbit the sun, as do the rest of the planets. Second thing, they must be large enough to be spherical. Now, is that going to run off the side of the... Nope, it's not. They must, to be a planet, a body must orbit the sun. Good. Be large enough to be spherical. Once a body reaches a certain size, so suppose we go out and we find an asteroid which is shaped like a potato and is not spherical, and we start adding more junk onto it, adding more and more mass to it. Eventually, you're going to get enough mass on that body, on that potato, to where it's no longer going to be potato shaped. It's going to crush itself into a sphere. Okay? Any object sufficiently large enough becomes a sphere, because that is the most stable configuration from a stable gravitational configuration. in the shape of a sphere, every point in a body is on the average closest to every other point. So eventually an object will become a sphere when it's big enough. Okay. And so both Pluto and Eris, as well as the rest of the planets, including Ceres and a handful of other asteroids, not only orbit the sun, but are large enough to be spherical. Ceres, Juno, Vesta, Pallas, all those asteroids are all spherical. Eris is spherical. Pluto is spherical. They all orbit the sun, so 1 and 2, check, check. Number 3 is the issue. Number 3 must have swept out its orbital neighborhood. Now, what in the world does that mean? Swept out its orbital neighborhood. Well, all this means is this. Think of the Earth. The Earth is the most massive thing within its orbit. You know, the neighborhood of its orbit. Orbital neighborhood, all that means is kind of imagine a little donut around the Earth's orbit. Just the region around the orbit. Okay? It's not just a line, it's like a region around the Earth's orbit. Virtually anybody in that orbit will eventually fall into the Earth because the Earth's gravity will attract it. Okay? And suppose we did it this way. Suppose we took a bunch of asteroids and scattered them all around the Earth's orbit. Well, eventually the Earth would clean those up. They would sweep it out like a vacuum cleaner. It would attract all those clumps of matter, all those little small asteroids, and basically vacuum them up onto itself gravitationally. Okay. The Earth has done that. Jupiter has done that. Mercury has done that. Uranus has done that. But neither Eris nor Pluto nor any of the asteroids have done that. Their mass is not big enough to have swept out their neighborhood. If their mass had been enough to sweep out the neighborhood, there wouldn't be an asteroid belt and there wouldn't be a whole Kuiper belt. So asteroids are not planets because they're members of this huge population of objects in the asteroid belt. And objects in the Kuiper belt are not planets because they're members of this huge population of objects that orbit in the Kuiper belt. No Kuiper belt object is big enough to have swept out the Kuiper belt and to have vacuumed up gravitationally all the other particles in the belt. So while Pluto and Eris check off points 1 and 2, they do not satisfy criterion number 3 and therefore are not planets. This definition was proposed and accepted in August of 2006, and at that point Pluto was no longer considered a planet because it didn't satisfy number 3. Okay. It did not sweep out its orbital neighborhoods, or its orbital neighborhood is jam-packed with literally hundreds of thousands of small icy bodies that Pluto and Eris and all the other Kuiper belt objects are not massive enough to vacuum up, to sweep out. Okay? Maybe vacuum up is better. Maybe number 3 should be written, a body must have vacuumed up its orbital neighborhood, gravitational vacuum. Okay? Pluto has not done that. No Kuiper belt object has, and no asteroid has either. Okay, so that's it for Pluto. There's a nice little section on Pluto. You ought to read it. Covers a lot of these points and a couple others also. Next up, we're going to talk about sort of the minor planet zoo. I think we'll call the next lecture, the next video, the minor planet zoo. And you'll see why we call it that next.